Alright, so in this video we'll be discussing about the first numerical that will give you the entire context on what type of numericals will you be going to get in your exams. So here we are doing the first numerical. I will be reading out the statement and then we'll write down the things that will be necessary from the statement part. The statement says, a hot iron ball of mass 0.2 kilograms is added into 0.5 kilograms of water at 10 degrees Celsius. The resulting temperature is 30 degrees Celsius. Calculate the temperature of hot ball. Specific heat capacity of iron is 336 joules per kilograms per Kelvin and specific heat capacity of water is 4.2 into 10 power 3 joule per kilogram per Kelvin. Alright, as the statement says, there were two things. First is the iron ball and then is the water. The iron ball is having mass 0.2 kgs, the water is having mass 0.5 kgs. We have to find out the temperature of the iron ball, but the temperature of water is given as 10 degrees Celsius. This is the final temperature. So we have to make this type of table. On one side we'll have to write all the things about that substance and on the other side we'll have to write all the things about the other substance. This is the final temperature that they both will be going to acquire when the thermal equilibrium is being established. So we'll have to find out T. This is specific heat capacity of iron given and that is specific heat capacity of water is given. Now again, same from the law of calorimetry, we know that heat gain. We have to find out which body is at the lower temperature because the body which is at the lower temperature will gain up the heat. Heat gain by the water. See how we can guess because we don't know the temperature of ball because the final temperature is 30 degrees Celsius. It means this temperature of iron ball is somewhat higher than 30 degrees Celsius. It means it is an heated object. And obviously this 30 is greater than 10. It means water is at the lower temperature. It will gain some heat to acquire this temperature of 30 degrees Celsius. So heat will be gained by the water equals to heat lost by iron ball because it was at an elevated temperature. Over this side we'll have to write the entire thing about the water and over that side we'll have to write the all the things about the iron ball. Alright, so we are getting into the formula that is m into c into delta T for water equals to m into c into delta T of iron ball. Alright, so let me shift it over here. Mass of water. Mass of water is 0.5 kilograms. So it is 0.5 into specific heat capacity is 4.2 into 10 power 3. Here an important thing is you have to match the units of units of mass and units of specific heat. Whether if here is kilogram, here should be kilogram. If here is gram, you'll either have to convert this into kilogram or this into grams. Alright. So this is our fortune that in this numerical both the units are same. So we'll not have to change the either of them. So 0.5 into 4.2 into 10 power 3 that is specific heat into change in temperature for water. This was the initial, this was final. So 30 minus 10 which gives us 20. Alright. So this is the heat gained by the water. What is the heat lost by the iron ball? Heat loss will be mass of the iron ball which is 0.2 kgs into specific heat, again this is kg, no need to change, 336 into change in temperature. This temperature was high, this temperature is comparatively low. So this would be T minus 30. This would be T minus 30. So all of the things we are having, we need to find the value of T. So after calculation, the value of T will come out to be as dash degrees Celsius. We'll solve this and we'll get the value of T. The value of T after the calculation comes out to be 655 degrees Celsius. So it will came out to be as 655 degrees Celsius. Alright. So this was the first numerical as given in the ICSE book. So we'll discuss one more numerical like this, and then I will take up your doubts. So let us now discuss the second numerical. The statement is, a metal piece of mass 20 gram is heated to a constant temperature of 100 degrees Celsius. Then it is added in a calorimeter of mass 50 grams and specific heat capacity of 0.42 joules per gram per Kelvin, containing 50 gram of water at 20 degrees Celsius. After stirring the water, the highest temperature recorded is 22 degrees Celsius. Calculate the specific heat capacity of metal. Specific heat capacity of water is given as 4.2 joules per gram per Kelvin. Alright, so from statement it is clear that they have given us three things. One is the metal piece which is at elevated temperature. Then they have given us specifications about calorimeter, and then they have given us specifications about water. Alright, mass of metal piece is 20 gram which is heated to a temperature 100 degrees Celsius. Then it is dipped in this water which is present in this calorimeter at the temperature of 20 degrees Celsius. See, water is present in calorimeter already. It means whatsoever is the temperature of water will be the temperature of calorimeter. Alright, so both will be at the identical temperature. And they have given us specific heat of water as 4.2 joules per gram per Kelvin. Alright, let us first see the unit system. This is grams, 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 and these specific heats are all in grams. So there is no need to convert. Now the thing is, we'll have to apply heat gain equals to heat lost. So now there are three things. We'll have to see out of these three which of them are going to gain the heat and which of them are going to lose the heat. So we know heat will be gained by the objects which is at the lower temperature as compared to the final temperature, and the heat will be lost by the substance which is at the higher temperature as compared to the lower temperature. Now we see that calorimeter and water at 20 degrees Celsius and the final temperature is 22. It means these two has gained some heat in order to increase its temperature. So it means heat will be gained by both calorimeter and water. Heat gained by calorimeter and water will be equal to heat lost by metal piece. This is the heat lost by metal piece. Now metal piece is obviously at the higher temperature, so 100 to 22, it means it has to lower its temperature, it has to lose some heat. So heat will be gained by two things. One is the calorimeter, other is water. Heat is lost by metallic piece. Alright, so we'll have to apply the formula and we'll get our answer. How? Let us see. So this is m into c into delta T for calorimeter plus m into c into delta T for water will be equals to m into c into delta T for metal piece. Alright, let us see. What is the mass of calorimeter? It is 50 grams. What is C of calorimeter is 0.42 joules per gram. So there is no need to conversion. This is in grams. This is also in grams. What is change in temperature? That is high temperature minus low. 2 degrees Celsius. So this is 1 for calorimeter plus mass of water is 50. C of water is 4.2. Again, this is in grams. This is in grams. What is change in temperature? 22 minus 20, again 2. Alright. Heat loss by metallic piece, mass is 20 gram. C, we have to find out. That is the question, that what we'll have to find out. We'll have to find out the specific heat capacity of this metal piece. C into what is change in temperature? That is 100 minus 22. So 100 minus 22. That is the thing that we need to find out. Alright, we are having each and everything. What is the thing that we are not having? That is this value of C, and this is the C of metal piece. After calculating, we'll find out the C as dash. What would be the units? Whatsoever is the units present over here, the same units will be of the C, because we haven't converted any unit. So it will be joule per gram per Kelvin of metal piece. Specific heat capacity for the metal piece is 0.3 joules per gram per Kelvin. Alright, so this is the answer that we'll be getting after solving this entire equation. Alright, so this was the second numerical, that is the second category on what else we can be asked in the questions. Till the previous question we have discussed about the temperature. Here we have discussed about the metal piece. One more variation was this, there is the addition of the calorimeter. One important thing, whatsoever is the temperature of the substance present inside the calorimeter, that will be the temperature of the calorimeter, and the heat will be gained by both the things, that is water as well as the calorimeter. So we'll have to add two equations. One is for the calorimeter, other is for water, and over that side we are having only one substance which is going to lose the heat, so it is like this. So this is the another type of the variation in numericals that you can expect. Alright, so you can solve now as many numericals as given in your book and spend your time on these numericals, because these are very important. So we'll meet up in the next video with the next concept, when the state changes from one state to other.